Assalamu alaikum. In this video, we'll be looking at two important concepts associated with the random variables, which are expectations and the variances. The expectation or expected value of a random variable is nothing but the mean value it can assume. It is the average of the random variable that we compute. It is denoted by this notation that you see, E of x. For discrete random variable, the calculations are somewhat simpler, which is we just sum up the product between each distinct value that we can achieve, and we multiply it by the probability of this value. Xi is all the possible values this can take, and Pi is the probability associated with each of them. We just sum them up. Now, if it is an average, why do we not see a division with the total count? It is because the calculation of the probability always already incorporates the division. So we do not see it here. We can also consider the probability, the mean calculation of this random variable or the expectation of this random variable as the weighted average. Because for a normal average calculation, you'll add up all the values together and divide by the count. Here we add up the values, but before adding, we multiply them with the probability, which can be considered as the weight associated with a given value. For the continuous RV, however, since it can take infinitely many different values over the given range, it is computed using the integral. This might seem intimidating, but the good news is that we'll never be using this function directly to compute the expectation. Here, the xi represents all the range over which this continuous random variable, all the values that it can have from this range, which are infinitely many, and P of xi is the probability function, which computes the probability over a given range for of this continuous random variable. We are going to have a look at this in one of the coming lessons. Consider this probability distribution for the random variable. You can clearly see that the random variable here can have three distinct values, 0, 1, and 2. And the probabilities associated with each of them are given, 0.2, 0.5, and 0.3 respectively. We compute the product of the value with its respective probability, and we get these values. Now we simply add them up to get the mean or expected value of this discrete random variable. Here, the expected value is 1.1. So the interpretation of this is that this random variable, because a random variable is representing the outcomes of an experiment, so you can interpret it as the experiment will have on average this output, which is 1.1. Consider another example. An instructor designed a pool of exam questions containing 4 hard, 5 medium, and 6 easy questions. She randomly picks 5 questions for the next exam. What is the expected number of hard questions? So here you see an application of the expectation of random variables. Let x be the number of hard questions in the chosen set. So now we know that the sample space for x is 0. There is no hard question, 1, 2, 3, and 4. 4 is the case where all of the questions chosen are hard. Actually, she chooses 5. So 4 of them are hard because we cannot have more than 4. We have only 4 questions in the set. So these are the possible values that random variable can take, 0 to 4. Then we compute the frequencies. Now, in order to compute, because the frequencies are not directly given in the data, but we can compute those. We know that the pool contains 4 plus 5 plus 6 questions, and we also know the counts of each category of question. So we can compute the probabilities of these functions. Here, if you look at all the possible combinations of 5 questions that the teacher can extract from the pool, it is by choosing 5 from 15 through the combination formula. And we get it as 3003. So all the possible combinations, including any questions from the pool, any 5 questions from the pool, we can have 3003 different arrangements for this. But we are only interested in knowing those arrangements which contain 4 hard questions. For that, we are going to split this data into 2 groups. four questions which are hard, and the remaining 11 questions which are easy. And we are going to choose, we are going to calculate the probabilities for each of them. So for the case where x assumes a value 0, it is that case when none of the questions included in those were chosen from the pool, they had included a hard question. So in that case, from the first group, we do not have any question included. So 4, we choose 0 from the 4, and we choose 5 from 11, because all of the questions were included from the remaining pool, which included medium and easy questions. This comes out to be 642. And the probability of having a 0 hard question becomes 642 divided by 3003. 3003 is the total number of combinations that we can have when any 5 questions are chosen from the pool. For one hard question combination, we choose 1 from the group of 4, and we choose 4 from the group of 11, because in total we need to have 5 questions. But this is the event when out of the 5 questions chosen, 1 was hard. So we have these combinations and these many combinations for the rest of the 4 questions. And this is calculated as 1320. Now the probability of having 1 hard question becomes 1320 over 3003. For 2 hard question combination, we choose 2 from 4 and the rest of the 3 from the 11, and the value is 990. And the probability for 2 hard question becomes 990 over 3003. For 3 hard question combinations, 3 questions are chosen from the hard question group, and the rest of the 2 questions from the rest of the questions, and we get 220 as the total number of combinations involving 3 hard questions. The probability becomes this. For 4 hard questions combination, we have all of the 4 hard questions being chosen, and the remaining 1 question selected from the other rest of the questions, and we get this as 11. The probability becomes 11 over 3003. We list all these frequencies here, and then we compute the product. 0 multiplied by this probability becomes 0. Then we multiply these respective values, and we get the probability, this sum as 4004 divided by 3003, which is 1.33. So basically what this means is that the probability that if the teacher is choosing 5 questions randomly to be put in the exam question paper, the expected number of hard questions that this 5 question group will have is 1.33. Of course, you do not expect 1.33 question exactly coming in the exam. It's either a 1 or a 2. But what the mean value indicates, as we've already seen, is it is the typical value. So you would expect either 1 or 2. Of course, there could be either in in reality, you can only have a value 1 or 2, but whatever value it is going to be very close to this. You should have you should not expect 4 questions coming in the 4 hard questions coming in the exam, although that those might be some rare cases and it might happen, but it has a very low probability. The highest probability is to have questions, and the number of questions in the paper from this hard pool is only 1.33. So you should expect either 1, 2, or maybe sometimes none of the hard questions being chosen. This we have already discussed. Of course, we cannot have 1.33, but this only gives you the sense of what typically you should expect, what number of hard questions will be there in your exam. Consider another example, and this is very interesting. A trip insurance policy pays rupees 20,000 to the customer in case of a loss due to theft or damage in a 5-day trip. And this is what these companies are advertising most of the times. And this is because of which people are tempted to buy the insurance policies. If the risk of such a loss is assessed to be 3 in 200, what is the expected cost per customer to cover? So the question is, if they're paying this much amount to a person in case of the said loss, how are they going to generate this much amount? How much cost they should be asking from the customer in order for them to be able to pay this amount in case of this loss. So this is done using the expectation values. Let X represent the amount which will be paid to the customer in case of this loss. The possible values of X are 0 when there is no such loss and 20,000 when there actually such a thing happen and this amount has to be paid to the customer. So we construct the frequency distribution table for the random variable. We have two possible values. For this value, the probability is 3 out of 200 because it is given in this data. So there's a chance of a 3 in 200. So we calculate this probability. And the rest is the chance that it does not happen at all. So for the value 0, the probability is very high. It is 197 divided by 200. How we got 197 is that we subtracted this probability from 1 using the law of complement, and we got this. Now, when we compute the products, we get 300 and a 0 here. So the expected cost per customer, which the insurance company has to pay, the average cost per customer the company has to pay is only 300. What does this mean? This actually means that if the insurance company only asks for 300 as the cost which they take from a customer when they pay for the policy initially, they can break even. And if they ask any amount which is above 300, it is their expected net profit. So they only need to. This is generally the tactics. They advertise that we're demanding only 300 rupees or so. Of course, it's not going to be 300. It's going to be value a little higher than that. Even if they demand 500 from the customers to purchase this policy, they still are making profit. The variance of a random variable is given by this expression. And this is the expected value or the average that we have calculated earlier of the deviation from of the values of X from the expected value. And we square them. It is very similar to the variance formula that we've seen for regular values. And this is what it can also be written as, because when we are calculating expected values, we are actually summing the values and their probabilities. But this time, the value that we are taking is the squared deviation from the mean. So xi is the values that the random variable can attain, and e of xi is the mean value or the expected value that we have seen just now how to compute it. We take the square of it and then multiply it with the probability of this value. The sum of squares of the differences of values from the expectation, and this is how we calculate it. We have this random variable with three possible values, 2, 3, and 4, and the associated probability calculations. We compute this deviation from the mean, and because the mean here is 3.5, it's given. We calculated this mean in the last video. And here, we've calculated the deviation from the mean. Then we compute the squared of this deviation. And finally, we multiply it with the probability to get these values. And the variance turns out to be 0.375. For the standard deviation, we only need to compute the square root of the variance. So in this case, we've already computed the variance as 0.376, and the standard deviation is going to be the square root of this value, which is 0.613.